Have you ever wondered how the planets move in our solar system? Well, a mathematician named Johannes Kepler wondered the same thing hundreds of years ago. Kepler came up with 3 laws to describe how the planets of our solar system move. The first law told us that planets orbit the Sun in elliptical orbits. This means that the planets' paths are not perfect circles, but they are oval-shaped. Ellipses have 2 axes, a major axis and a minor axis. Half of the major axis is called the semi-major axis. You'll need to know this for Kepler's third law. Kepler's second law showed that a planet's speed is not constant. It is faster when it is closer to the Sun and slower when it is further away. Kepler's third law, the law of periods, helps us understand the relationship between how long it takes a planet to complete one orbit, its orbital period, and its average distance from the Sun. Kepler looked at the data for the planets Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Uranus and Neptune had not yet been discovered when Kepler was alive. Kepler noticed a pattern. The further a planet was from the Sun, the longer it took to complete one orbit. Let's look at some of the data. By definition, the Earth is 1 astronomical unit from the Sun, and it takes the Earth 1 Earth year to complete one orbit of the Sun. Mars is further from the Sun, at just over 1.5 astronomical units, and its orbital period is longer than the Earth's, at around 2 Earth years. Mercury is only 0.39 astronomical units from the Sun, and it only takes Mercury 88 Earth days to complete one orbit. Kepler came up with a mathematical rule. He showed that if you cube the average distance between the planet and the Sun and divide it by the square of the orbital period, the answer is roughly constant for every planet in our solar system. We now know that if you use the semi-major axis rather than the average distance, you get an even more accurate result. So Kepler's third law shows that the square of a planet's orbital period is proportional to the cube of its semi-major axis. And we can use this relationship to work out how long it takes a planet to orbit the Sun if we know its semi-major axis, and vice versa. Though Kepler did not know it at the time, the constant value he had discovered was dependent on the universal gravitational constant and the mass of the Sun. About 70 years after Kepler published his laws of planetary motion, Isaac Newton published his work on the law of gravitation. Newton showed that the gravitational force between 2 objects was proportional to their masses and the distances between the objects. This law included the universal gravitational constant. About 100 years after Newton's work, Henry Cavendish was the first to accurately measure the value of the gravitational constant. Thanks to Newton, we know that Kepler's third law is a consequence of the law of gravitation. By applying what Newton discovered about how gravity works in the universe to the relationship that Kepler discovered, we can express Kepler's third law as a mathematical equation and use it to work out the mass of the Sun. And we are not limited to our own solar system. Kepler's third law can be used to learn more about worlds around other stars, which we call exoplanets. Kepler's laws were a major breakthrough in our understanding of the solar system. They helped us to understand how the planets move, and they also helped us to predict their future positions. Kepler's laws are still used by astronomers today to study the motions of the planets and other objects in space.